Okay, so there are formulas to write down, and you just got to write them down for now. Okay, sine of u plus v, or x plus y, or alpha plus beta, they are two angles, okay, equals the sine of u cosine times the cosine of v plus cosine of u sine of v. And if you want to put your parentheses, you can, but your u's better get tails on them really quick, obviously. Okay, the difference. Can anybody guess what the difference maybe is?
The opposite.
Okay, so it's the sine of u times the cosine of v minus the cosine of u sine of v. I personally write it sine cosine. I rather switch the angles, not the functions, but doesn't matter. No, because it's multiplication. So you only take the cosine and the sine of each angle one time. You never take the cosine both in one term. It's sine cosine.
Why does one side have cosine and the other side doesn't?
Well, this is the formula. Like, this is the formula over here.
Such angles. Okay.
We could derive the formula if you would like, but I don't think you would like. Okay, so then they have the cosine. If you would like to derive the formula, you come in with me some other time and we'll derive it so you understand where it all comes from.
We'll go hard.
Okay, equals cosine of u times the cosine of v plus, minus, opposite sign, non-cosine, minus sine of u sine of v. The difference of u minus v. Anybody want to venture a guess on this one?
It's cosine u, cosine v plus sine u and
Yep.
sine v.
Cosine u, cosine v plus sine u sine v. Now, I didn't make a big deal out of it, but I would assume you would all know that addition would be the sum and the subtraction would be the difference, correct?
Yes.
Okay, so these are formulas you just have to remember. On the test, they will be listed. I will have that, and you have to tell me that at the top of the test.
Okay, that should be easy.
Okay, so you do have to make some connections with it. Sine is the same sign, isn't it?
Same
Sum and
sign.
sum. And it's sine, cosine, cosine, sine. It doesn't matter again, but if you're taking the sine of u in the first one, you're taking the sine of what in the second one? V. And I always usually say first, second angle, that kind of stuff. The other one we're going to do is tangent. We are not going to do secant, cotangent, because all you have to do is do sine, cosine, tangent, and do what with them to get the other ones? Reciprocate them. Okay, so tangent of u plus v is the tangent of u
Sine.
plus tangent of v divided by 1 minus tangent u tangent v.
Gross. That is weird.
The difference, I think you guys could guess the difference one.
Multiple.
Tangent of u minus tangent of v over
1 plus
1 plus
tangent of
tangent u
v.
tangent v. So what these do for us is we know We can do the sine, cosine, and tangent of anything that has a reference angle of 30, correct? Anything that has a reference angle of 45, anything that has a reference angle of 60, or anything that's a quadrantal. We can do all those. But can you do the sine of 75? No. But can you break down 75 into two angles you know?
Probably, yeah.
Yeah.
30 and
Okay,
45.
so if I do the sine of 75 degree, we can do the sine of 30 plus 45. Could I do 45 plus 30?
Yeah.
Yeah. Can you think of a subtraction? You're obviously going to have to get out of the first quadrant, yes?
220. Could you do 220? Like subtract them?
220 is 220 an
sorry,
angle
no.
you know?
Never mind.
You have to get an angle you know outside of the first quadrant, right?
So then would it be like would it have to be a negative then?
No.
180.
Like if you took 180 minus something, but 180 minus what gives you 75?
180 minus 20.
Something you don't know. So is there one we know? So in the second quadrant, we know 150, correct?
150.
We know,
One.
I can't think, 120.
Where are you getting the second quadrant from?
The second quadrant.
135.
No, I know that, but like why?
Because this is a 30-degree reference angle, correct? 150 is the 30-degree angle in the second quadrant.
Oh, okay.
60-degree, and we know 135, right?
135. 180.
Well, yeah, 180, but we already...
Yeah.
In the fourth quadrant, we could use 210,
210.
225,
240. 240.
240. Okay, so could you use any of those? We could go to the third quadrant even. But I got to get a difference of what?
Different of 75.
75. And you can mix first and second or whatever.
240 and 2.
Because those are angles we know. We should know the sine, cosine, and tangent of those angles.
240 and 135.
It's up to you. What?
Wait, never mind. That would be it. Never mind.
So then you've got, we obviously have to do something with 45 degrees, correct? Or 225 or 135. Why would that be?
Because they have 5.
It has a 5. You've got to do something with that.
Uh-huh.
So I need two angles that I know. Let me write the fourth quadrant that we know. 270.
270.
We know 300.
3.
We know 315. We know 330.
330 and 360.
There's at least one pair up there.
There's a pair up there. And I'll even write the first quadrant. I didn't write them in order. I just kind of rambled them down. I need to get 75 when I subtract them.
Why does the bottom left one only have 3?
Because I put 180 up here and I put 270 down here. And I didn't write 360. So this one would actually have 5. I just put them in different places.
How about 225 and 150, Mrs. Nick?
So if I took 225 minus 150,
4.
do I get 75?
Yeah.
Okay. Do I know those two angles, or should I be able to figure out their sine, cosine, and tangent? Yes. So everything is available to you. So we'll do, how about we do both? We'll do it one here and this one.
Okay. Sine.
So I have sine of 75, and this is how I want you to write it on your paper, equals the sine of 30 plus 45. Could I put 45 plus 30?
Yeah.
Yep. So this is my u, this is my v. And then you plug it into your equation. I can't have mine on my paper, but it says sine of the first one,
So
sine of 30 cosine of
Cosine of
45 plus cosine of 30
Sine of 40.
sine of 45.
And then we will solve
What is the sine of 30?
sine of 30.
1/2 cosine of 45
Square root of 2 over 2.
cosine of 30
Square root of 3 over 2.
and sine of 45.
Square root of 2 over 2.
Well, I got 4 for denominator on the left and 4 for the right, so my common denominator is what?
4.
4. So I get 4 and then square root of 2 plus the square root of 6. Can I add the square root of 2 plus the square root of 6?
No.
No. So the sine of 75 is the square root of 2 plus the square root of 6 over 4. Now, when we do the subtraction, should it come out exactly the same way?
Yeah.
Okay, so we said sine of 75, and Kale said that it was equal to the sine of 225
Or
minus 150.
or it could be 120 and 45.
Yep, it could be different. He just came up with that. Nobody else was coming up with anything. So it better come out to be the square root of 2 plus the square root of 6 over 4, correct? Okay, so then we have the sine of 225 cosine of 150 minus the cosine of 225 sine of 150. Okay, so 225 is in the third quadrant and sine is negative there, yes?
Mhm.
So it's negative. What is the reference angle to 225?
45.
45. So what's the sine of 45?
Square root of 2 over 2.
Square root of 2 over 2. Do you see how I decided my positive negative and then I just went with my reference angle? We'll do it again. Okay, 150 is in the second quadrant. Cosine is positive or negative in the second quadrant?
Positive.
Negative.
Negative.
Yeah.
Cosine is x.
And it's gonna
So
be
what is my reference angle to 150?
30.
30. So what is the cosine of 30?
square root of 3 over 2.
Square root of 3 over 2. Now do you see what I did,
Yeah.
Ethan?
Not really.
Okay, well, watch again. Smoke and mirrors. Okay, 225 is the third quadrant. Is cosine positive or negative in the third quadrant?
Negative.
Negative. So I decide my negative, and then I do my reference angle. Reference angle to 225 is
45.
45. What's the cosine of 45? Square root of 2 over 2.
Okay.
Okay,
Ish.
and then
Sine of 150
sine of 150, second quadrant, sine is
positive
positive, so I don't have to worry about that. Reference angle is
30.
30, and the sine of 30 is
1/2.
1/2.
So the denominator
So,
would be 4 again.
The denominator is 4 again. And a negative times a negative is a positive, and a negative times a negative is a positive. So I get the square root of 6 plus the square root of 2. Did I get the same answer?
Yes.
Yes. Okay. So sometimes it may say use the sum formula. Sometimes it may use the use the difference formula. Sometimes it may not tell you to do it. Just say find it, and you get to pick. Okay. On the test, I will say the sine of 75. Do it once with addition and once with subtraction.
Wait, so you want us to go sine of 75 equals what we're doing and then have the formula under?
Well, you didn't have to write the formula. I mean, I want to see this.
Can
Yes.
it be next to it?
You should be working what direction? Down. The first step can go next to it because that's like the proof step, but then you should be working down. Okay, that's nice and easy when they're in degrees, but what if I put them in radians?
Feel like it could be harder.
So the sine of, I don't know why I keep doing sine. Let's do cosine. Cosine of pi over 12. Okay, this is how I do these problems. First of all, I think of the two denominators. All of my denominators in radians are going to be 2, 3, 6, or 4. Yes?
So could you do
Okay.
pi over 3, pi over 4?
So I immediately say 3 and 4 would be my denominator to get 12, wouldn't it?
6 or 2 as well.
Right.
But 3 or 4
But-
would be easier.
Whatever. I pick 2 or 6. Because if I had 2 and I had 6, my common denominator would be 12. And if I had 3 or 4, my common denominator would also be what? 12. So do you want to use 2 and 6 or 3 and 4? 3 and 4. Okay, so we've got to get 3 and 4. So we're going to do the cosine of something pi over 3. Actually, I better not put those in there. Because it could be like pi over 4 minus pi over 3, correct? Does that make sense? So it's going to be something pi over 3 and something pi over 4. And it could be a 1, right? It could be a 3, it could be a 2, depending, that we're going to use. And we've got to get 12. Well, I'm going to tell you right now, if I have pi over 3 and pi over 4, and I get common denominators and I add them, am I going to get 1 in the numerator? No. I am not going to get 1, am I? So addition probably isn't how I'm going to do this, is it?
Subtraction.
Subtraction. Okay.
Would you do 2 pi over 3 minus pi over 4?
Well, if I have 2 pi over 3 minus pi over 4, would that give me...
They give you 1.
Well, let's think about this.
No.
Because this would be over 12, right?
So that would be
So this would be 8 pi
Never mind.
minus 3 pi.
Never.
So that would give me 5 pi over 12. Okay? So on the right track, we just got to think about it.
Pi over
6
3
pi.
minus pi over 4.
Pi over 3 minus pi over 4. Okay, so pi over 3 minus pi over 4.
So 4 minus 3 would be 1.
Oops, that was supposed to be a 12.
Oh, well, yeah.
So 4 pi minus 3 pi, would that be 1 pi?
Yeah.
Yes. Okay, these are ones you're going to probably have to think about a little bit harder. Okay, so then we know that it's going to be pi over 3 minus pi over 4. So then the cosine rule is cosine of the first one times the cosine of the second one. Opposite sign. So we did subtraction, so we put a
Plus
plus
sine.
sine of the first, sine of the second. These aren't really that even hard to remember, guys. If you say them while you're doing them. Okay, so I need the cosine of pi over 3.
Pi over.
60.
So I need the cosine.
So that would be 60 degrees. So that would be 1/2.
Okay. And then I need the cosine of pi over 4.
Square root of 2 over 2.
Plus the sine of 60 degrees, or pi over 3,
Wait, what?
right here.
No, you said cosine. You needed the cosine of 1/2. So you
Square root
need-
of 3 over 2.
I'm pretty sure it said sine, but maybe not.
No. Over on the cosine parts.
Yeah.
I thought you said, sound like you said cosine of 1/2.
No, cosine is 1/2.
Oh.
Okay, and the sine of pi over 4?
Square root of 2 over 2.
So I get the square root of 2 plus the
Basically,
square root of
it's the same every time.
6. No, it's not the same every time.
Seems like it's the same.
But why is the cosine of pi over 12 equal to the sine of 75?
Complementary.
Because they're complementary angles. Because what is pi over 12? 12 goes
15
into
degrees.
what?
15 degrees.
15 degrees. So Those are complementary angles, so their sine and cosine are going to equal. Are you going to find your answers look a lot alike?
Yeah.
Yeah, because you're dealing with 1/2 square root of 3 over 2, square root of 2 over 2, over and over and over, correct? So they are going to look very similar.
Huh. That is weird.
Okay, find the exact value. Of the cosine of A. Okay. I hate it when they're long problems because I'm trying to write it. Cosine of U plus V. Given that the sine of, let me make sure I'm in the right one. The sine of U is 12/13. And your 0 is less than U, which is less than pi over 2. So where does that tell you U is at?
Quadrant 1.
Quadrant 1. And cosine of E equals negative 3 over 5. From pi over 2 is less than V, which is less than pi. Which is in what quadrant?
Second.
Second quadrant. Okay, so we need cosine of U plus V. So formula is
Cosine U, cosine V minus sine U, sine.
cosine U, cosine V, minus sine U, sine V. So we need to fill things in, right? Well, I know that the sine of U is 12/13, so that can go right here. So 12/13. I know the cosine of V is negative 3/5. But how am I going to find the cosine of U and the sine of V?
Pythagorean triples.
Yep, they are Pythagorean triples, or I make my right triangles in those quadrants, correct? So this is the first quadrant. So first quadrant angle. Sine is 12/13. So I use the Pythagorean theorem, or no, it is 5. Because it's a 5, 12, 13 triangle. It's a Pythagorean triple. This triangle is in the second quadrant. And they gave me cosine, so that's adjacent and hypotenuse, correct?
Yeah.
Pythagorean triple is 4, or you use the Pythagorean theorem and you come out with 4. So we're talking about this angle is V, and this angle is U. So what is the cosine of U?
Cosine of U is
5/13. And what is the sine of V? 4/5. So am I doing it any different?
No.
No.
There's no range of degrees.
Oh, I forgot my 1 here. Okay, you will have to find common denominators, but a lot of times they work out. So my common denominator is
Whatever.
65. So I have negative 15 minus 48. So 3, 5, 63. Negative 63 over 65. Do I know what U plus V equals? Nope. Do I care? No.
For next period,
Okay.
for third period, the 7th graders that go for PE, instead